Why are people lazy when it comes to quoting prices? Let's say you've just had a long Saturday afternoon at the shop and you get your receipt through and it comes to £51.32 and your friend asks you, well, how much did you spend today? Now, normal person would say, well, it's perfectly reasonable to kind of round that down, and you could say instead of £51.32, you could say, oh, I spent about £50. Now that's perfectly fine. You could say I spent £51. You could say, if you wanted to, I spent £51.32, but they might look at you a bit funny. So this idea of rounding to different significant figures is a really important part of physics, okay, and it's useful in different situations such as estimating, but also in the general concept of significant figures and how you know how many figures to quote answers to. So if you need a quick recap on what significant figures are and how to use them, watch the next couple of minutes of the video. If you need to skip forward, then please feel free to do that if you're confident already. So a number like our price of £51.32 is given to four significant figures, 1, 2, 3, 4, to each side of the decimal point. If I was to round it to three significant figures, the last digit rounds down to become a 0. Okay, so the last digit becoming a 0, if it's a 0, it doesn't count towards our significant figures total. If I was to round it to two significant figures, the 3 after the decimal point would also become 0 to leave us with £51. So the last digit would become 0 as well. Now, one significant figure would mean that the next digit along R1 becomes a 0, so we round it to 50.00. So that's actually what you're doing when you say I've spent £50 instead of £51.32. Okay, so that's that same number to those different levels of significant figures. Now, obviously, you can round up as well as down. So let's have a look at another example. This time the figure is 7,682. So let's round it to three significant figures. The 2 this time becomes a 0. Don't leave it blank. It still has to have the same number of digits. To two significant figures, the 8 can't become 0, so we round up. So it rounds up to 77,700 because the 8 is larger than 4. Now, next to one significant figure, this one can catch people out. Well, the next digit is a 7, so again that's 5 or higher, so we round the first significant figure upwards, so it's now 8,000 in total. So that's that same number to three different versions of significant figures. Now, why is this all important? So at GCSE, you will have been told how many significant figures to give an answer to, and it's usually a mark on each paper in physics. However, all your answers at A-level physics should be given to the correct number of significant figures, and you can be penalised for not doing that in a couple of points in the paper, but they won't tell you where. So just get used to do it all the time, follow these rules, and you'll be fine. So how do you know what the correct number of significant figures is? Well, it is equal to the lowest number of significant figures given in a question. So let's look at an example with some numbers in it and see if we can use that rule. So let's say we have a situation where a person's got a mass of 61 kilograms, they're accelerating at 5.26 meters per second squared, and we're trying to find the force. So force equals mass times acceleration. Let's times those two things together. It comes to 320.86. Now that's currently 5 significant figures. 61 kilograms is 2 sig figs. Acceleration is 3 sig figs. So what we do is we choose the lowest one of those and give our answer to 2 significant figures. So that then becomes 320.00 overall. Now, if you were to take a slightly trickier example, like in an exam question such as this one, now we're not worrying too much about the equations here. We are trying to calculate power. So let's look at our values. We can work out work done and then divide that by time. So work done is going to equal force multiplied by distance, and work that out and then divide that by the time to find the power overall. So let's do the calculation first, then we can talk about significant figures. So we've got the force is equal to 1,500, the time is equal to 0.35, and the distance equals 0.35, and the time is 0.85 seconds. So overall, if we were to solve that, it comes to 617.64705824, and so on, so on, so on, so on. A really long number. So how many significant figures do we need to quote that to? Well, let's look at our numbers. We've got force is the 2 significant figures, time is the 2 significant figures, so is distance. So we quote that to 2 significant figures, meaning that's 620, because we round up the 617. Now, this has a special situation, a special significance when we are talking about practicals. So why are they important in physics? Well, obviously it gets you marks on an exam, that's one thing, but if you go to a degree level of any science really, it saves time when quoting answers, but it's really important when we talk about practical work. Let me show you what I mean. So let's say you measured the time taken for, let's say, a car going down a track, or could be anything really, and you have a mean, you have 3 different times, and we need to find the mean. Now we need to know how many significant figures to quote it to. So if we are to measure with our stop clock, and the stop clock we can see is just a regular stop clock, it measures to 2 decimal places, minutes and seconds. So we've got, sorry, that should say seconds and hundredths of a second there. So we've got 1.26, 1.29, 1.30 seconds. The mean happens to be 1.283333 recurring. Now, our answer has to be to the same number of significant figures as the original values in the question. Otherwise, we're implying we can read our values to a greater precision than the stop clock can. So our answer here should be 1.28 to 3 significant figures, because that's what the values going into the mean are. We can't give more than that because our stopwatch only gives to 2 decimal places. So the answer has to have the same precision as the data that goes into it. Otherwise, it implies you've got better measurements than you think. So there we go, that's significant figures. I hope you found that helpful, and helps you with your calculations with A-level physics.